Let me further introduce myself. I was born and raised in Hong Kong, so I had a bicultural education. I'm bilingual and bicultural. At that time, Hong Kong was still a British colony. So at one time I held a British passport, even when I came to the United States to study. And I've been in the United States for more than half of my life, 50 some years. I went to UC Berkeley to get my degree in astronomy, and then I went to the East Coast, partly because NASA Goddard Space Flight Center was over there. So when I was in grad school, I essentially was already sitting in NASA. I was funded by them through a research assistant to finish my graduate studies. My graduate study specialty in stellar evolution and nucleosynthesis, which was a hot topic at that time. I will talk about that a little bit in today's presentation. And after I graduated, I worked as a contractor for NASA, and eventually as joined NASA as a full-fledged civil servant. I've worked mainly on the operational side of NASA astrophysics and space science missions. So I'm not per se a research scientist, unlike people who publish papers and do research. I actually help research scientists to carry on their experiments or observations by using NASA assets. So I deal a lot with engineers and the implementation side of how to carry out a space observation. So I was a Hubble Space Telescope operations astronomer. So down here, you can joystick a telescope and sit there and say, focus and do this and do that. But for space operations, it's a different story. So I did a lot of that, taking into account all the space limitations and hardware limitations. And later on, I did a lot of in information technology application. I was director for NASA Astronomical Data Center. So I'm back in Silicon Valley now. So I know a lot about information systems and computers. And towards the end of my career, I decided to concentrate on education. So I was director of Lunar and Planetary Science Academy. I trained over 77 interns. Now they have all gotten their PhD by now. It's 10 years ago. To be the next generation of NASA scientists. And so the last job I had was as education and public outreach for NASA Goddard Space Flight Center, the Astrobiology Institute. So in a sense, I dabbled in a lot of things. In a sense, I was very fortunate. I was able to take a cross spectrum across all the NASA missions because I was in public outreach, helping people to understand or simplify some of the rather difficult concepts in press releases. Okay, let's get on to today's topic. First, happy Mid-Autumn Festival, because next Tuesday is the Mid-Autumn Festival. It's when you have the harvest moon, the first full moon, closest to the autumnal equinox, which is September 22nd. But the harvest moon will be the 20th. That's the day when you have the full moon. So they don't always coincide because one is solar, the other is lunar. So for those who are from the Far East, that's a big festival for family. Just give you a little bit of the Chinese legends because of the shadows in the moon. I think in the West, there are other legends about a man chopping down a tree or something like that. There are various legends, but in China, there are at least 2 or 3 prominent legends. One is about this lady called Chang'e, which is a princess. And the other one, Yu Tu, is there's a bunny on the moon. So what happened was she's married to a tyrant. One day he got so angry he should chase her, and so she all of a sudden she rose up to the heavens and eventually went to the moon, and that's her palace with the bunny next to her. And the reason I mention these two terms because you might encounter them in space missions, because China lunar mission chose to use these 2 terms to designate their missions. The Chang'e, they have, I think, Chang'e 3 or 4 already. There are 4 missions to the moon. And U2 is the robot, which is roving around on the surface of the moon. So you may encounter these 2 terms twice. I mentioned these, they mean the princess and the bunny. And this it's just one of the legend. Like United States choose to use Greek mythology to name the spacecraft, like Juno. I forgot what the other ones are, but there are a lot of Greek mythological figures that we use to name our space mission. And China choose these two. Okay. Okay, today's outline, all about the moon. There are moons in the solar system. What do we know about them? Okay. And why are we going to the moon? What if we had no moon? And today we specifically talk about the moon formation miracle and moon's role in making Earth a habitable planet. And the reason I talk about this, because this is another example of God, the master designer at work. That in Reasons to Believe, we often talk about the Belgic Confession, that God chose to reveal himself both in scripture and also in nature. We as scientists often confront people who do not believe in God because they say science contradicts what's said in the Bible, but we say no, because in the Bible it says, the creation actually revealed the invisible qualities of God, as in Romans 1:20 says. It can be clearly seen and being understood for what has been made, which you can touch, you can experiment, you can observe. So we are without excuse. So today we look at God's creation, particularly the creation of the moon. And we know it's actually a show for the character of God and his loving care towards mankind. Okay, references. If you have not read Hugh Ross' Improbable Planet, I highly recommend it. In fact, today's a lot of material actually closely follow what he says there. But I often joke with him, I say, I got the pretty graphics. So today, just enjoy the pretty graphics from NASA. Jeff Zwirik also has a blog, a very short article called Quick Collision, Beautiful Moon. The next two are just science articles, but they're very good description about the moon formation scenario. Nowadays, you'd like to watch videos. I don't have much time to play the videos, but if you like to, you can Google these. This is very nice and short video. I think the last one is kind of long, but the first three are very short ones. National Geographic has one called Moon 101. The moon formation simulations are actually taken from simulations done by Dr. Robin Canuck, and another video called Evolution of the Moon. Okay. When we talk about the solar system, we live in the solar system. We live on the planet on the solar system. We often ask this age-old question: what is our place in this vast universe? Why are we here and how do we get here? Here are the questions that all mankind asks, as of old. So we're trying to answer these questions every day. We quickly run through some of the things that make us so special. The solar system is actually located in a very unique place in the Milky Way galaxy. If you find a place for your family to live, you want to find a nice neighborhood. And God in his loving care has actually placed us in a very nice location, very nice neighborhood. It's a rather quiet neighborhood. It's not near the galactic center. This is a conceptual drawing of the Milky Way galaxy. We don't have a picture because we live inside it, so we cannot go outside of the galaxy to take a picture of it. But we have look-alike galaxy. But this is actually the artist's conception of where we are in the Milky Way. The sun is here where the solar system is. Here is the galactic nuclei. We are not near the galactic nuclei because that's too much ongoing, too active. It's spewing out high energy radiation all the time. You'll be fried in no time. If you're anywhere near the galactic center, high energy radiation, you're scared about X-rays, gamma rays. Some people worry even going to take X-ray too frequently. But God placed us out there in the outskirts. We live in the suburbs, as far as the galaxy is concerned. And also we don't live close to a 5-lane highway. We're not in the spiral arms. We're in between. So you don't want to live next to Highway 5 or someplace, 101, where you hear traffic all the time. And the same way it is for our solar system. We're not exactly on the spiral arm. We're in between in a quieter place. And we also belong to a I would say, a very ordinary star called a middle-aged star, a G-type star. G-type is a spectroscopy classification. It's a middle-aged, a not very interesting star. In fact, we prefer it not to be too interesting, because if it's too active, it's again spilling out high energy radiation or doing too many funny things for us to be able to live a good life. Okay, let me explain a little bit, because it's part of my PhD area of study. I just very quickly run through this. Why a G-type star? Why do we don't want to live in a star which is what they call the early type star, which is a larger mass? One reason is because many of you understand the periodic table in chemistry. All the elements in the periodic table are gradually built up from the beginning of the universe till now. There's some elements that are older than the others. In the beginning of the Big Bang, there are only 3 elements that was created. So if you live in these early type stars, all the elements you have in the periodic table are hydrogen, helium, and maybe a little bit of lithium. So you cannot have life as we know it with just 3 elements like that. Where's carbon? Where's oxygen? So the first generation star with the nuclear furnace in the center start actually creating the other higher level elements. Okay, this is a bigger picture showing what elements are created in the second generation stars. And later on, subsequent generation stars gradually build up the periodic tables. So this is what we call the star recycling. The early star, because they're relatively massive, they burn very quickly, they spill out, they supernova and bequest whatever they had. Sometimes the entire star was annihilated when they explode, giving out all the higher level elements back into the interstellar medium, and they remake it into the next generation star. So the subsequent generation of stars has higher level, higher, what they call metal rich. By metal rich is anything that higher than hydrogen and helium. That's the terminology they use, not what we mean by iron, okay? And subsequently, they build up all the way to iron. And so, for this table, it shows the periodic table, the most abundant elements used in human biology. You read this, these elements, it just reads like the label on a vitamin bottle, because these are the things that you need to live a good life. I used to be in Washington, D.C. area, so our chapter president is also a medical doctor like Dr. Wu. He often called these the vital poisons. You need these things, a little amount, a trace amount, in order to live healthily. So he said, you need these, but you need to be living in an older star in order to have these elements as your basic ingredient. That's why the sun needs to be G-type star. It cannot be too early. It has to come later on. It cannot be the first or second generation star. It has to be subsequent generation. So God planned it such that our planetary system is, the parent star is a G-type star, middle-aged star. So we know God showed forth everything for life in a very fine-tuned fashion. There are many parameters that require for advanced life, not just ordinary bacteria kind of life. A lot of people believe that life in the bacterial form can pervade a lot of areas, maybe even our solar system, although we have not found a single one so far. Okay, I'll explain later why. But for higher advanced form of life, anything higher than the bacteria, amoeba, or anything, you require the exact conditions, very exact conditions. And they are very atypical values. They're not the run-of-the-mill value. You cannot just have, you have heard about the little warm ponds. That won't do it. By the way, that won't do it. Today we skip over all these things about galaxy cluster and galaxy. Milky Way is also a very special galaxy, but we skip over all this. Hugh Ross in the upcoming book will talk more detail about our special location in our Milky Way galaxy, in the special galactic cluster. But today our planetary system, is 1 in 10 to the 112th possibility, and it has 137 parameters. Our planet itself is this Earth, which is a very rare one, very unique one. And our moon, although there's smaller number of parameters, still fitting those 27 parameters is not easy. So everything has to be just right. To have so many coincidences, that's what we call a miracle. You want a miracle.
Does this parameters and statistics means every single system in itself require 1 in, for example, galaxy cluster 1 in 10 to the 53 power by itself, just so without independence of this other
Yes, that's correct.
parameters, correct?
That's correct. That's why when you add them all together,
wow,
it's 1 chance in 10 to the 705th power. So it's almost impossible in terms of probability, but then that just illustrates. By the way, Hugh Ross, there's a table in Reasons to Believe website you can download. There are over, I forgot how many, 200 and more parameters. They outline all these and with the reasons behind it. That's publicly accessible, by the way. If you want to, I can send a link later on to you and you can give it to your the chapter members. That is a very useful website, web page to know, what are the fine-tuning parameters that are required for advanced life. You can have, the upper, 4 or 5, but you don't have the ones below. You won't have life. And today we just talk about moon, just as the smallest one. If you don't have a moon, you may not have us today. So that's how important it is. And I'm trying to explain how important the moon is for us here to be able to ask this question. Oops, I jumped too fast. And I think most of you heard about the anthropic principle.
Oh, Dr. Cheung?
Yes.
I have a friend who's an atheist, and I was talking to him that I was reading this book, Evidence That Demands a Verdict by Josh and Sean McDowell. And
yes.
on page, in the prologue, it says life requires the right type of moon. If Earth did not have a moon of the right size and distance, it would be uninhabitable. So I just wanted to ask, are you going to be covering that later?
Yes, that's the whole point of this talk. Why need a moon? I go too much into preamble, but I just want to quickly go through it.
Okay,
about
thank you.
Yeah, I'm coming to the main thing very soon. Okay. This idea that the universe is specially made for us, it seems to be very self-centered, but that's true. These are not a concept that's created by Christians. By the way, the anthropic principle was established by mainly the 3 scientists who started this concept was actually non-believers. I think of these 3, only Arno Penzias is a Christian. Fred Hoyle, I think most of you know, is not a Christian. That's why Big Bang was coined by him to actually laugh at this idea of a beginning. Arno Penzias say because he developed, he actually discovered the background radiation, 3-degree background radiation, which confirmed the Big Bang. So he won the Nobel Prize. He said, astronomy brought us to this particular instance. And the universe is created out of nothing. One's very delicate balance needs to provide exactly the condition required to permit life, which has an underlying, one might say, supernatural plan. Okay, these are not, they are not me. Okay, I'm just run-of-the-mill astronomer. But these are very famous people who have done great things. They say he thinks there's a supernatural plan underlying all these. And Fred Hoyle, even he joked around, he's another believer. He's just looking at an overall look at all the physics and chemistry. He say a common sense interpretation of facts suggests a super intellect and monkey with physics as well as chemistry. Somebody has done something about it. It's not random. These things cannot be randomly, generated. There's no way the universe just happened like this because somebody did something. Somebody has intervened. And physicist Raymond Dyson I don't know how to, qualify him. He's Jewish. I think he may be agnostic. I think he acknowledged there's a deity, but he doesn't want to have anything to do with him. He said, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe, in some sense, knew we were coming. As if the universe is all prepared for us, human beings. So this is a very interesting thought from somebody who's not a Christian. He doesn't say I was in the beginning God. He didn't say that. He looked at all the physical laws. Physicist Freeman Dyson, I think he passed away last year. He's a very famous Princeton physicist, and his daughter is also a very famous physicist too. He say, well, I don't know what happened, but then when I look at all these things, he's a very high overall look. He say, in some sense, the universe is prepared for us. He knew we are coming. So the physical laws actually bears imprint of our master designer, our God. Okay, now come to the real thing. This is a familiar picture for most of you. Solar system has only 8 planets. I'm sorry, Pluto has been demoted. Someday I'll tell you why Pluto has been demoted. If you ask the question later on, I have time, I can explain why Pluto has been demoted. There are only 8 large planets, but it's very unique. It's different from all the exoplanet system we have discovered so far. You have heard about exoplanet. That is not our solar system, but the other solar system that has been stellar system that have been discovered the last 15 years mainly. Okay, oops, I jumped too fast. Here's the statistics. This exoplanet archive you guys can access. So they're being updated quite frequently because they keep on adding. Starting from year 2000, there was only a few. That was when the hoopla started. They used Hubble Space Telescope and all sorts of things to try to discover the exoplanet. Partly the problem is because the planets are so faint compared to the brightness of the parent star. So it requires some very precise technique. There's a different technique to try to discover exoplanet. By radio velocity spectroscopic technique. By transit, that's easier, that the shadow pass in front of a star, so the brightness vary. By timing, that's slightly more difficult. By direct detection, that's rare. It has been rather close to do the direct detection, which is by parallax sometimes, by geometry. Here we are in 2021. It's not that we haven't discovered anything, because we have to be extremely careful when we make that announcement. So there's a lag, by the way. It's not that in 2016 we discovered so many. They have been confirmed, okay? So I expect this continue to rise. There are a lot of candidates that's been discovered, but they will not confirm it until much later. Maybe next year you'll see this jump up, okay? So far we have confirmed, full confirmation. You might discover it by radio velocity. They have to go and use a larger telescope to do other things so that they confirm it's really a planet. It's not a glitch in the telescope or something else. If flies happen to walk across your mirror or something of that sort, okay? And in that, it confirmed there's 795 multiple planet system. So a star does not just have one planet, but multiple planets, just like our solar system. Here's an exoplanet gallery. There are many, many more. I just take a snapshot of some of them. Some of them are false color, obviously, but by spectroscopy, they know what color it should be if you will go there and actually take a picture of it. So they are all very different than our sun and our, of course, our Earth. They're looking for a terrestrial planet. That's the price they want to get. They want to find a twin of the Earth. So far, we have not been successful because most of the planets they found, this is Jupiter, this comparing from Jupiter, a large planet, Jupiter kind of planet. And Jupiter is not a rocky planet. You cannot go to Jupiter and find a surface to stand on. Only the planets close to the sun, like Mercury, Venus, our Earth, and Mars, a rocky planet, what they call the terrestrial planet, that you can stand on. Think about NASA missions to Jupiter and perhaps the other outer planets. They're thinking about using submarines, or they just crash the spacecraft in there. They say Jupiter is just a very heavy fluid. So when you go into Jupiter, they actually crashed a spacecraft in Jupiter not long ago because that's the end of life. There's no way you can land somewhere. So you can increasing, you're submerging into that fluid. The pressure just crushes spacecraft. So then,
Dr. Cheung,
yes.
is it true that the way stars form, that having a solar system around a star is probably the rule, not the exception?
Probably. Although we cannot see planetary system around some stars because of the brightness contrast is extremely difficult. It's highly likely from the physics and from the planetary formation. Likely you see a lot of disk, debris disk around the star, the way stars form. It just condensed from nebula, and there's always a leftover debris disk around it. So where debris disk condense into little rocky planet or gaseous planet, we don't know, but likely they are. Whether we see them or not is a different story. But the prize we're trying to get at is a terrestrial Earth-like planet. But so far we have not been successful. And what we mean by Earth-like, we're going to go into that later on. Okay. And now multiple planet system is a comparison, just a few. There are many. You go to Google search, you can find many of them. These are the ones that are the most like Earth. There are two systems that also have 8 planets. But you compare the size, this is true size scale comparison. Most of them has much larger planets, likely gaseous. And their orbital distance from the parent star is different than Earth. Okay, this is Kepler. The reason they all Kepler something is because they're all from this Kepler mission. With the purpose of actually, Kepler is a mission that just focus in one area of the sky, so spacecraft to focus, keep taking pictures, deeper and deeper pictures to detect this faint object. And there's only one area of the sky they focus on. They're not swirling around the whole sky. And so some of the data analysis has not been finished yet. But just from that one mission, they discover many planets. And these are some of the examples. You just look at it, you know they're different. This one, Kepler 47, the earlier ones, they say, well, they're 2 gaseous giants, but we have these little guys here. Where are they? As far as they can see, we can find them. They're not there. And this one is the most like us. Okay, but then again, we are very unique. That's the point. We're very unique. We cannot find a solar system like planetary system so far. Less about the Earth. This one they call the pale blue dot. Okay. So when we go to look for this Earth-like planet, what are we looking for? Because we want to have, the reason we want Earth-like is we want to find extraterrestrial life, ET. Everybody wants to find that. So we define what is the limits and requirements for life. What are we looking for? So this is Chris McKay here in the Bay Area in NASA Ames Research Center. He's one of the astrobiologists. He say that temperature, liquid water, light, photosynthesis, nitrogen, and oxygen. It seems very obvious to us living on Earth. We all need all those. It hasn't rained in California for quite a while. We want water. We want temperature, the right kind of temperature. We don't want it to be too warm. We need light. We need photosynthesis for plants to grow. We need oxygen and nitrogen. Those are very obvious ones. There are more detailed ones, depending on the particular kind of life. Okay, talking about the moon. Our moon is very unique, just within our solar system. It's a comparison of our moon to other moons in the solar system. There's Earth, there's moon, there's us, okay? Now, some of the planets have a lot of moon, like Saturn. But you know where Saturn is? We cannot draw Saturn on this slide because they're huge. You can just draw the perimeters here. Jupiter, Uranus, Neptune, they're huge compared to the tiny little moon surrounding them. So in terms of relative size, our moon is humongous compared to the parent planet. So in terms of extension in the sky. The moon takes up like what I call half a degree, or whatever we say is 1/4 the diameter of the Earth. So it's big. You always see the moon. You use it, the nighttime. It's just like a big lantern in the sky. You see it everywhere. But for the other planets, you might not see all the little moons. Some of them are so tiny. Uranus is huge. These little guys over there. So we are very particular, just in terms of the solar system. Our moon is very particular. It stands out. So I jump another one again. Okay. Well, we had no moon. Just let your imagination run. The first one is a very natural thing. We have no natural light at the sky. There's so many romantic poems composed of the moon. So the cultural implication is pretty big too. It's a Chinese poems. There's thousands based on the moon, about the moonlight and all the stuff. And one important one is don't have any eclipses. Very dramatic eclipses. I'm going to go into that a little bit later on. One very important thing, reason life on Earth is so good. We have 4 seasons. We need the seasons for growing plants for a lot of reasons. We have no tides. Okay, tides are extremely important. No magnetic field, no natural shield against the frequent impacts.
I have a quick question.
Yes.
The seasons, I thought that was mostly because of the tilt of the Earth and how it, as it orbits the sun, the angle of incidence of the sun's rays or whatever, or how close or far.
Exactly right. That's correct. But the tilt in other planet wobble around so frequently, you won't have any steady seasons. I'm going to go into that later on. This is essentially a summary of what I'm going to later on.
Oh, okay, thank you.
The reason we have such steady seasons, the 4 seasons, is no coincidence. If you live in other planets, sometimes there are only 2 seasons, one extremely hot, one extremely cold. You either fry or freeze. But we have spring, summer, and winter, okay, and autumn. It's very nice. The tides are extremely important for, we'll talk about that later on, okay? All these imply there will be no life. So that's why I say nowadays, people say, you search for exoplanets that have moons if you want to search for ET, extraterrestrial life. You don't just find Earth-like planet, you find an Earth-like planet with a companion natural satellite like our moon. They say that's what you have to find. You really want to find life as we know it on the Earth. So that's what, the search for extraterrestrial have gone to, because they realize what the moon has done to us is no small thing. They don't just light up our night sky. There are many other things it does to Earth. Okay, eclipses. I just want to dispose of it earlier. It's very interesting. God placed the moon not too far and not too close. The angular size in the sky for the sun is 400 times wider than the moon, but it is also 400 times further away. So exactly right. So many of you are familiar from very basic science courses, how the solar eclipse happened and how the lunar eclipse happened. The lunar eclipse is when the Earth gets in between the sun and the moon, and the solar eclipse is when the moon gets in between the Earth and the sun. Although they have different sizes, but the distance is exactly right. So you get to see all these spectacular things. This was the picture. I should have replaced it, but I don't have time. In 2019, it was a total lunar eclipse. But I give you my little picture that I took early this year. There was a blood moon in May 26th this year. I got up at 4 a.m. in the morning. I set my alarm, took my little handheld camera. I didn't want to take out a big gun, too lazy, and just snap it. And I got it. I was surprised. This is the blood moon at full eclipse. It actually looks bloody. I just stand outside my garage and just snap these things. Just wait. And this is when they're coming out. You can see some lunar features, and we're just completely out. So about half an hour, and I went back to bed afterwards. I just took these with handheld camera. And then if you Google, you can see a lot of very, very pretty of the blood moon taken by professionals of the May 26th eclipse. But you want to see an upcoming full moon eclipse, I think it's coming up in November. You're welcome to go and observe it. The good thing about lunar eclipse is almost everybody on Earth can see it because of the geometry. But for solar eclipse, not everybody can see it. Okay. Now, what did the moon do to make Earth habitable? It's a very important thing. We wonder, the planetary scientists wonder, when Earth was first formed about 4.3 billion years ago, it was like hell. It was condensed from the protoplanetary disk, hot with volcano. That's what they call the Hadean period. How does it turn into that wet Earth at present? That's a very legitimate question. We don't know how to answer. Where does it get its water? Where is its energy? Where do all these nutrients come from? It doesn't start out like that. You go to this place, you won't live there. So let's try to answer this question. So a lot of questions. People question this part about NASA missions. Why do you have a NASA? You can feed the poor on the Earth. Why are you spending so much money? Because back in the 60s, it was the Cold War. We go to the moon not just for pure scientific reason, also for political reason to win the race against the Soviet Union. But there's a very strong scientific reason for going to the moon. Because we want to know the early history of the solar system. We want to find out what happened in the early days. But you couldn't do that on Earth because Earth has a lot of geological activities and weather. The erosion by water, you completely clear out everything. You don't know what happened way back when. So how do we find out? Luckily, we have an archive, a rocky archive, very close to us, and that's the moon. The moon does not have an atmosphere, does not have plate tectonics, which means volcanoes, earthquakes, and the like. So it preserves everything from day one. So from the first 1 billion since it was formed. So that's one reason why we went to the moon and we still want to go back. You want to understand solar system history, unlock the history of planetary formation, you need to go back there. And here's this is a real archive picture. You can download it from the web. I forgot which astronaut this is, but he's gathering lunar samples. One of the most valuable things the astronaut brought back. It's not just the pictures, not just the national fame that we won the moon race. It's those 800 some pounds of moon rocks. They're still being researched. By the way, they're archived under environmental condition in Houston. Some of the vault has not been opened yet because they're waiting for better techniques. If you need to get hold of moon rocks or moon dust, you need to write a proposal with scientific justification and actually ask for them. And they will send you an appropriate amount, very small. I had worked with moon dust, real moon dust before, but everything has to be returned after your experiment. They won't let you hold on to anything. Whatever you've done to it, even you semi-destroy it, whatever is left, you need to send back to Houston. That's the rule, because that's a national treasure. And so my interns, some of them are still studying moon rocks because you can still go and request access to it if you have scientific justification. So this is just echoes Psalm 19 that says these rocks will cry out. Echoes Luke, and in Psalm 19 say they have no speech, they use no words, no sound heard from them. But the voice go out into all the earth, the words to the end of the earth. So creation continually testifies something to us about what happened in the beginning. In this case, in our earth history. Okay, these information are all found out after Apollo program. Before, we are not certain, we guess that might be the case. We know, well, the gravity, just from the orbital elements, they're about 1/6 of the Earth. The surface temperature is terrible, so you can feel for the astronauts. Daytime high, not comfortable, nighttime high, not comfortable. So you either roast or you freeze. That's why they have this nice space suit. Keep you kind of comfortable, not really. Now, these are the things that tells us something happened way past. There's absolutely no water on the moon. You might have heard about this big thing about they find a little bit of water, but those water are not, do not originate from the moon. Those are water given to the moon by the comets and the meteorites that impact the moon. That we understand. The moon itself has no water. It's deficient. They have the rock so they can analyze the composition. They're deficient in nitrogen and carbon. So these are important ingredients for life. The moon cannot have life without nitrogen and carbon. There's seismic and magnetic data. Now, the astronaut didn't just go there and come back with rocks. They left something there. They left a number of instrumentation there that we're still gathering data. The seismic instrument left there. There was a laser reflector, which is very important. We're still tracking the distance of the moon to Earth daily because the laser reflection, very precise. We know there's no iron on the moon, the deficiency compared to the Earth. And there's no volatile elements like the light elements compared to meteorites. So from that, we deduce a lot of things. From that, we deduce one thing very important. The moon must have a violent past. They make it compared to the Earth. Now, the two seems to be look alike, so close by. How come the moon is like this? Whereas Earth is wet, the moon is dry. The Earth has all these nice nitrogen, carbon, oxygen, all these things. The Earth definitely has iron core. We have magnetic field. So what happened? So one of the conclusion, one of the hypotheses at that time was the moon play an important role for Earth's habitability. So this is astrobiology poster from, actually it's the poster of Goddard Center for Astrobiology. Why is Earth wet and alive? Why? We often reference this book called Rare Earths. There are two geologists, by the way. They conclude that Earth is very unique. Just from all the things they look at Earth. Say we are one of a kind, wet and dry, alive. We can even find the same thing in the solar system. Let's just say they're exoplanets. So why is that? We don't understand. Okay, so something happened. In Hugh Ross spoke, they also talk about what makes a planet habitable. You have to be in the right place at the right time, but there are other quantities you need to quantify. So they're only, well, the most important one, liquid water, we mentioned that. So the obliquity, the tilt, which we mentioned earlier. There's tidal force important, the rotation rate. How fast you rotate. One day is 24 hours now, which is kind of comfortable. Imagine you live on a planet that rotates every 4 hours. You'll be dizzy, but besides being dizzy, there are a lot of things that are not very good if you're rotating that fast. There's an ozone layer. Okay, that means there's oxygen. The ozone is very important because it blocks out the harmful ultraviolet rays. We worry about the ozone hole nowadays for good reason, because there will be skin cancer. But we do need some ultraviolet. Otherwise, plants won't grow. We know photosynthesis. Light has to get through. It cannot be completely thick atmosphere. And there's an astrosphere, okay, where how far are you from the sun, which is an important part. So a solar wind will kill you too. So there's this plot about where you are. The Earth is dead in the middle in this habitable zone. Mars is barely on the edge. That's why people want to go to Mars. Maybe there was life there. Mars current condition cannot sustain life. They talk about Europa, which is a natural satellite. Jupiter, maybe it may have life, but it's too far away from the sun. That has to do with distance. It's too cold. So they conjecture about life on Europa. It's not what we say carbon-based life. It might, because carbon might be frozen, even if they have dry ice there. So maybe in the kind of life. So We don't know. And there are other habitable planets. Not these guys. You're trying to find things, but these are the very first order magnitude to say, well, what you call a planet habitable. But this is all based on the Earth knowledge. Okay, we talk about the moon formation hypothesis before the Apollo mission. You might have heard about this. These are all hand-waving arguments because they're hypotheses, because we have no data. We don't know what to do. So we can say, well, they just form together. And one simple thing is the two clumps of things. One form the Earth, the other form the moon. So, for want of data, you can say anything you want. We don't know, at that time, we don't know the composition of the moon. We don't know the composition. We know the composition of the Earth, we don't know the moon. But now we found out the moon is completely different from Earth. So they cannot be formed together out of the same cloth. Well, I can say out of the same, this is a material. How come one form was completely different composition? It could not be. The other was fission. Again, that same argument striking down. You cannot break apart. The other argument against fission is because they say, oh, the Earth was spinning so fast. So one block get swept out. So the other block forms the moon. But you calculate the momentum and the energetics, it won't happen, because once you spin it out, how can you stop it from spinning and make it to orbit? Some force has to stop it from spinning, so it coagulates and then they form in an orbit. It does not just happen. If you swing it out, it would just be gone. Okay, the capture is another thing. The capture, a lot of people say there's some natural satellite we think of the other planet that actually capture a large asteroid that captured to be a natural satellite. But again, because the moon's composition is so different than meteorites, we say it cannot be. Plus, again, the energetics requires something to happen for it to be captured. And what force make that? So that doesn't work very well. Okay, jump too fast again. So after the astronauts came back with all these rocks after the analysis, in the early 1970s, Dr. Robin Canuck, this is actually her PhD thesis in Southwest Research Institute in Colorado, together with her research team and the thesis advisor, suggests this very, at the time, rather improbable thing. There was a collision because all these things point to the fact that the moon has violent paths. Something happened, caused it to lose all the water, all the light elements, lost the iron even. So what they proposed was that now luckily the computer power has come up in those days, and starting in the 70s, supercomputer and all that. And, Colorado has one of the largest simulation centers, supercomputer centers in the United States. So you cannot repeat history because there's no observation you can observe now, but you can do computer simulations, varying all the parameters. I know that very well because my own thesis is also a computer simulation, but mine is way back when, so it's much simpler simulation. They're doing 3-dimensional, 4-dimensional with time, so simulation. Varying the mass of the impactor, varying the mass of the proto-Earth, what happened, the angle of impact and all that. And this is a very famous movie. You can go and watch it on YouTube. It's sort of a glancing ball at the right angle. The impactor is almost as large as Mars itself, the current Mars, with an iron core. But the iron core gets embedded in Earth, so it lost its iron core. And because the impact is so violent, everything got evaporated. All the volatile, the light elements got spilled out. And Earth itself also got affected a lot. Earth is completely, boiled up, become very hot. The next one is the real simulations with time. You know, I don't want to run the movies, because it takes a lot of time. When the first impact, you can show the debris coming out like a tail, but then the energetic is just that the glancing bolt, the angle of impact is very important. It starts to circulate. And then this happens in a matter of days and years that this start to form. And out of this, eventually the moon condenses. And they managed to fit so many parameters from the moon rock. So nowadays, this becomes really the leading theory for moon formation now, because many people have tried to repeat this simulation with different parameters, different initial conditions. They came up with the same answer. We think this is pretty sure. Dr. Robin Knoop is still doing the more detailed simulations, adding more nuances to it. And so far, until today, almost 30 years, it still stands, this theory. So most people think that can explain, they don't just explain one thing, they explain multiple things about the moon data and our current observation. That's why it's become very successful so far. So what does this moon forming impact imply for Earth? Of course, we talk about this impact. So what did it do to Earth at that time? Earth at that time was, in the beginning, was just this crazy, you know, hot proto-Earth. It has a very thick atmosphere. If you read Hugh Ross' Improbable Planet, you know, in day one, Earth was sort of void, and also darkness cover Earth. Why? Because it had a very thick atmosphere. The sun and the moon likely was already created, according to the stars, not the moon, okay? It's already created, but you can't see anything. You know, here, when in the analysis of Genesis 1, God created the heaven and the earth. That was actually a present perfect tense. So it's already created when he talked about that. So all the things were there, but so for somebody on earth, you can't see anything until day 3. Day 1, God said that there be light, and day 3, then 4, God said, day 4, God said, you know, there's moon and the sun. It's when after the lunar impact, the Earth's original thick atmosphere was cleared off through this impact. So everything was gone. The curtain was lifted at that time. Light came in, although that was not the clear atmosphere as clear as we are now, but it started to become more transparent. So that's why in Genesis 1:3 it says, "Let there be light." The first time for someone on Earth, you can see light instead of pitch darkness, because that gloop above us is already gone. If you were there at the time, because there was no life at that moment. Of course, this impact, the impact that bequests to Earth a lot of mass and density, especially iron core. Proto-Earth at the time they calculated was not as heavy as now. It doesn't have as much iron, but it added to the Earth's mass and density so that it can hold off just the amount of water vapor. Most of the planet, the little planet, the terrestrial planet, are dry because they say you don't have enough mass to hold on to these light elements. H2O, those are very light elements. You lost all of them. Only a giant planet, the Jupiter and Saturn, they have lots of hydrogen and helium, all that you want, because they're massive. But these all these Mercury, you know, you can't hold them because they're just too light. Okay, Mercury is another story. It's too close to the sun, so the sun boils off all the water. Now, increase the iron core to enable a strong and enduring magnetic field. And the reason for the magnetic field is so important, I go further into that, okay? It's because it becomes a radiation shield for life here on Earth. We know we have water, we have light now. Now, the radiation shield is extremely important for anybody on Earth. Now, comes the interesting thing about radiation hazard. Space is not such a benign environment for astronauts, even for pilots, airplane pilots. They all wear Geiger counters, by the way. I personally know 2 astronauts in Goddard space flight. They are just mission scientists. They passed away because of cancer. the space time is not that long. We all conjecture, but this small number, because only that many astronauts has gone into space. They die pretty young. We wonder whether the cancer is due to the fact that they have been in space. They're outside the protection of Earth's magnetic field. That's why space station has very strong shielding, but that's nothing compared to if you have solar flare, even high energy solar flare, that's no help. You're practically fried if you're not that dead. Then by the time you come back to Earth, the damage is already done. So radiation comes in different forms. There's solar X-ray, solar wind. Solar wind is actually high energy particles. The galactic cosmic rays can be very high energy. They're mostly made up by supernovae. They're spilling out not just mass. The radiation travel long. These high energy particles travel long and far. Gamma ray bursts is very high energy. There's one theory about dinosaur being killed. It's because gamma ray burst very close to the gamma ray burst and also supernova very close to Earth at that time. And they may happen together, and that's why the radiation itself is enough to kill off all the high advanced life. There's extragalactic cosmic rays. There are all sorts of things bombarding the Earth all the time. So if we didn't have that shield, they would be troublesome. By the way, there's another radiator very high, close to us, is Jupiter. Jupiter also is the largest radio source if you're into radio at all. It's a radio noise if you are into radio. It's constantly send out radio signal, okay? Just a natural, it's a lot of noise. So you need something to shield human being on Earth from all this bombardment of these high energy particles. You wouldn't want to all the time.
Sorry, I have a question about radio waves. They're relatively low energy waves. So would they still affect life? Because radio waves they're longer wavelengths. They're not high energy.
There are a lot of debates about that. Because people say that you don't want to find a house that's next to the power lines.
Right.
Because all power lines emit low energy radio waves.
Okay.
There's also the debate about cell phones.
Cell phones, yes.
Okay, so very
cancer.
low energy. Most people say they don't matter, but I can say I'm not a medical person. I'm not a radiation health person, but NASA is actively studying all this because we want to go to a farther away place than the moon, even Mars. By the way, one reason NASA pulled back the Mars manned space flight program is because of this.
Okay.
Right now, we don't have technology to have a live astronaut arriving at Mars at the current space transportation system because the radiation hazard is simply too large. Apollo program, we are extremely lucky because Apollo astronauts were on the moon for just a few days. And luckily in those few days, we don't have a large solar flare. It's relatively benign time. And they're back within like 1 or 2 weeks total, including transit time. So NASA is looking at technology. Well, if there's a rainstorm, how do you run across, the parking lot in a rainstorm? You do it fast, then you won't get a sweat. So they're trying to find a fast transit, but nowadays the technology, how do you fly a spacecraft faster than what we are flying? We don't know, okay? So there are also propulsion study. That's one way to do it. The other way is find shields. But you cannot add shields without adding mass, and mass is extremely expensive to push up to space to overcome Earth's gravity. So essentially, you're in a bind. Are you going to commit a human life to such hazardous condition, knowing that they will do permanent damage to the health? So some of my interns says, well, I want to go to Mars. It's a one-way ticket. I told them, I'll go anyway. I say, by the time you'll be married, you have children, you have your wife, ask them first, do they want you to go? Because you may not return because you're committing yourself to known radiation hazard, very high, much higher than whatever X-ray, whatever dosage you take. Being medical personnel, people know, you're not so simple. You do a PET scan, the gamma ray there. You exit the room, okay? Even my dental technology to take my mouth X-ray, they run out, behind the shield. And now you're sending astronaut there. So the radiation is tremendously important. So what is the benefit of magnetic
Thank
field?
you.
Yes. Protects us from sun's charged particle. The sun is the biggest source of this radiation. Of course, there's always occasional galactic and supernovae, all these things. It's a pushback against the sun's what we call solar wind. Solar wind is not just a wind, it's charged particles coming at us like a wave. The next one may illustrate it better. Here's the animation so you can show. When the solar flare hits, all the radiation just hit North Pole and South Pole. So the magnetic field sort of shielded us. So near the pole is not as good, but if you want to study the magnetic field, you go to the poles because that's when the magnetic field all bunched together. And that's why you have auroras, very pretty auroras. I work with scientists who major. He actually went to, he actually was a Caltech graduate student, but he went to University of Alaska just to study aurora. Just a resident there to gather data. It's very pretty. Why they're pretty? Because the charged particle actually discharged there and make the light show for you. I've been to Alaska and it's very pretty light show. You go north enough, you may see them. Minnesota, Canada see them all the time. But in Alaska, it's so also things. Then when the charged particle actually discharge, occasionally there's been very disruptive when there's a solar flare. I think one time Canada even have an impact to the energy grid because it's hundreds and thousands and millions volt hitting down on Earth. Your energy grid is not designed to sustain that. So the only way you can do it is turn off and let it pass. So whenever there's solar flare, all the satellites, they will choose to turn the bottom towards the sun, or they may just choose to just turn off so that all the electronics are off, then until a safe passage, then you turn them back on. Otherwise you'll be fried. And that's just one hit, that's enough. So that's extremely important for us here, living down on Earth. On the surface, you don't have to worry. Earth's atmosphere also help us in that sense. Oops, still jump too fast. Okay, the other things. Why did the moon hit is so important? We think, okay, we don't know where the Earth's radioactive isotopes comes from, so much of it. It's likely come from that impact. In the impact, Earth lost all its water. There's no way when you got hit with that. Everything is melted. The moon is, the impact itself, of course, is completely disrupted, but the Earth's surface, down to a certain depth is also disrupted. So everything got outgassed, gone. But where does our water, current water, our ocean, all these come from? There's still a lot of study ongoing, but we think it's from outgassing. How does the outgassing come out? You have to depend on something to spew it out. So earthquakes is actually useful. Although in California, we don't like earthquakes. But all these tectonic activities are useful. The tectonic plates moving actually force some of the things deep in Earth's interior out. So they say that's sufficient. They computed that's sufficient to actually add back an ocean to the Earth, although it's may not be as deep as today, but they be sufficient to give us water. So the water is originally from the Earth, because rocks also contain water, by the way, but you have to force them out. And the moon, ultimately, when it's formed, that's why we talk about the tilt. You have to have a shepherd to guide this tilt so that it's stable. Otherwise, we're wobbling around. I forgot which planet actually wobble around from the equator to the pole all the time. And you don't want to live in such a planet, okay? You can stand still. But the thing is, you don't have stable climate. You don't have the one face facing the sun all the time. It's so steady, 23 degrees, and you move around, and the tilt is slightly different, so that you have, spring, summer, autumn, winter. It stabilizes the thing. in fact, another example is the Saturn's ring. How come Saturn's ring is so beautiful? Actually, it's a number of very small satellites stabilizing it. So that you have this ring of, the rings are not solid, but they're all particles. They all guide them into a steady orbit. So that's why you can see the reflection of such pretty rings around Saturn. They have guiding satellites. So keep it there like shepherds, the talks, shepherding them so that you don't go out of line. So the moon actually has a gravitationally is very, very calculated, very accurately. It stabilizes. And another thing, the head itself, originally when Earth was formed, the rotation rate is tremendously fast, 6 hour day. 6 hours. So when the young Earth guys talk about 24-hour day, I say, hey, come on. Earth's rotation has never been 24 hours and never has been and never will be. Because in the beginning it was 6 hours only. But the moon, as I said, it has been stabilizing Earth's rotation because it keeps moving away. The gravity is such, if you do the dynamics, it's gradually moving away from us. And the laser instrument, they also tell us we are measuring the distance. It's gradually moving away. And by moving away, the tidal interaction actually slows us down. Like a skater, it just stretched out his arm. So it's gradually slow. It's actually a moon-Earth system. So the two just tied together, you slow it down. So it gradually, nowadays, we have a stable 24-hour day. You have night and day, very steady. And God said that if you can do away with my covenant with night and day, you can do away with all my promises to Moses and all that. So this is God's design. In his law, also shown in the system we live in. God made this impact. Yes.
Why is it necessary to have a 24-hour day? You said something about if you have a 4-hour day, you'll be dizzy, but then it'll be annoying. But...
you need some period. It may not be 24. It's always 23 and something. It's not exactly 24, but there's an order of magnitude thing. It's very different than 4. Okay. Mm-hmm. We are used to, we know only 24 hours. You can do a lot of imaginary experiment. What if it's 20? Of course, you go to the other planet, you can experience that because they rotate at a slower rate or faster rate. It's designed getting busy. It's just life on Earth is adapted to that already. At least we know life as we know it. We only know what kind of life so far. This sustains us very well.
Okay.
So I have no better answer than that, other than that. Nowadays, we know 24 hours is very good for us. We all have a biological clock that's clocked to that. A lot of animals has that. What if we suddenly change that? The thing is, it's constant. I don't think the 24 has any magic, but it's a constant to a certain, magnitude. I think 24 doesn't matter, or 20 doesn't matter really much. But if you go back to 6, I think it's drastic change. So I need the biologists to come in and the medical people to come in and tell me what health effect it has on us if it were only 6. Okay, I think you might get used to the dizziness, but then the other effect to that.
Okay.
So the moon actually literally slows us down from the day it's formed as a solid body.
Yeah, I guess I could see how it would be very annoying if it was like every 4 hours, every 2 hours you'd have like night dark, and it would just be annoying. Yeah. But other than that, I don't know, like it would screw up everyone's sleep schedules unless we were adapted to that.
But you have to think about the plants and animals too. The plants, how do they grow? Okay. Yeah. I don't know, like in Alaska, they have extra long days, they have long seasons, but only for a season. The plants grow very well, but if it's constantly that long or constantly that short, it will be another kind of plant life that we know. So anyway, all the things we know has been adapted to that.
Yeah. Okay.
Okay. So we talk more about the, come to the point about the detailed element compositions. I think this planetary embryo that they came in, originally our Earth was depleted of carbon, nitrogen, and sulfur. These are very important ingredients for life, but these are all endowed by this impactor. and the iron core actually, they think sent to the Earth, and so added to our magnetic field. And that was actually a paper in 2011. So it could be, okay, at least that's the best theory they have. And at first, Earth is mainly silicon. We don't have all these things, which is very important. You know, our DNA, we have these things very important as the basic components. If you don't have this element, enough of those elements, then you'll be in trouble. Of course, sun has them, but to have them condense into this protoplanetary nebula and to condense into a planet of that composition is extremely important. So all the planets, including, you know, the moon itself, does not have these. So it's very interesting. The Earth's composition is very unique compared to other planets, compared to the moon. Okay, I think I need to go a bit faster. These are more detail, you know, it's like an eye chart, but if you want to go into more detail, these are the things that make up the Earth's continental crust. And this we are which familiar with, and which we can build our industry on. Okay, we have a lot of industrial metals, the precious metals, the rare earths was very important for computers. These are, you know, you can hardly pronounce these names, but they're extremely important. If you don't have them, you don't have the land civilization. You don't have these, some of them, you don't even have life as we know it, carbon-based life, you don't have DNA. These are the basic components. These things read like a vitamin bottle, but these things are extremely important for advanced civilization. These iron-loving elements, extremely important. Okay, now I've talked about the moon, but then, you know, subsequent to moon formation, there are other things that happen. Why do we need a shield for impactors? There's one big whack way back then, but there's continually, there are other rocks or asteroids or meteorites that come to Earth that didn't help us very much. As we say, the history of life is punctuated by major extinction and major speciation events, not gradual evolution. The major event in the geological clock, we know we had dinosaurs at one point, we don't have them anymore. There are a lot of interesting species, we no longer see them. We can only account for them because there might be some events that happened way back in the past. We can account for the Earth's general features, characteristics by the moon impact. But subsequent to that, there are other things that happen. And then again, another big simulation. This is not Robin Canoe, but there's another guy. They call him the Mountain Man. I forgot his name now. I remember his nickname. He came up with a scenario about the large planets. These are guardian planets that switch orbits. This is real simulation that shows that. It doesn't matter whether it's Neptune or Uranus or Saturn or Jupiter. In the simulation, when you put together this protoplanet of this and let it run in the computer, it's called the Grand Tech model. Planetary migration is okay, Leveson. Okay, Leveson. Here you put down the initial condition. It's a dynamic simulation, let it run. You see the planets are not always in the same orbit as we see them now. They are now far away. But at one time, these two big guys actually move very close to the sun. Okay, you can see the little guys, the Earth and all these, they may not form completely yet. They may be just proto-Earth, proto-Venus, proto-whatever, but they came very close. And then they start moving out. This all has to do with energetics, with the disk composition, the dust and the gas and all that. You know, there's drag and there is all the dynamics. They just put it in and let it run. And that's what actually happened. You can see the history, 4.5 billion years ago, 4.1 billion years ago. That was about the time when the moon formed. They're very close and they start moving out again. Okay, and eventually 3.8 billion years ago, they start moving to the current position roughly, and things start to clear out. Why they clear out? Because when they switch positions, it's a very dynamic situation, a very disruptive situation. A lot of the planetary debris were cleared out, were kicked out to the outer solar system. Okay, So explain where the common asteroids now reside. We have two major reservoirs on comets and asteroids nowadays. At one time, it's all throughout the protoplanetary disk. They say there's a Kuiper belt. We know there's an asteroid belt, which they think may be a planet that did not get to form. And here we come Jupiter and outer planets. And outside of Neptune, there's a Kuiper belt, which has a lot of icy cometary kind of debris. So, but these things continue to come into the inner solar system and continue to come into Earth, around the Earth environment. So it's a rather hostile environment. It's like, in this collision derby out there, if you're Earth, just moving in his orbit, good old orbit, but somebody will come in and try to collide with you. So you need to watch for falling rocks. So Earth has been hit quite a few times. So here's where the moon also comes in. Okay. We'll move now. Throughout Earth's history, now we have another mission which is still functioning right now called Lunar Reconnaissance Orbit. There's an unmanned mission. Actually, the reason for sending it was actually planned for a future manned mission, because the Apollo astronaut just went to a couple of places on the front side of the moon. Okay, the Chinese mission just went to the back side. The reason they have to be in the front side because they need to communicate with Earth. It's a hazardous mission. They want to be in contact with Houston all the time. And the only way they have is to be in the front side. By the way, the moon is in tidal lock with the Earth. The moon also rotates and the Earth also rotates. It's only that because the rotation rate is the same. That's why you always get to see only one side of the moon. You rotate at the same rate. So you never see what I call the backside. That's not dark side, by the way. The dark side also sees some sunlight, but just we don't see that backside. This, they went back to take detailed photograph or detailed altimetry data. What is altimetry data? Is the height, because all we see is a two-dimensional image. Do you know where this is Maria? This is actually a flat land or it's a highland? We have no idea because it's all flattened out. So Lunar Reconnaissance Orbiter has very powerful laser. They bounce it off the surface of the moon and actually find out three-dimensional the heights of the mountains or the flat area in the moon. So they map out the backside of the moon. So there's significant difference. This is the front side, which we are very familiar with. You see the bunny there, you see the man on the moon, you see all sorts of things there, depending on your imagination. The backside is completely cratered. Lots and lots of it. It's a simulation of how many craters were on the moon. It's backside. It's a real simulation, an animation of it. So of course they overlap. We have an intern that actually try to count craters. When they come in the whole summer, just count craters, okay, with fresh eyes, and they actually find new craters. And how come Earth is not like that? You say erosion, no, but we're very lucky. We got hit very few times. The moon actually shielded Earth. So he got hit really bad in the backside. His front side hardly got hit, and that means Earth didn't get hit. It's our natural shield. So we thank God for that. We got hit very few times. A few times, dinosaur died. We will not hear that then, so it's okay. So it acts as a natural shield. Okay. Besides the moon, I mentioned the two big guys, Jupiter and Saturn. They're also our guardian planets. There are other asteroids that actually come into the inner solar system as a natural orbit. And they can wheel a little bit off and they can hit Earth. There's the asteroid monitoring team that actually sometimes you see a headline news and say, oh, there's an asteroid that is a close Earth encounter. But most of them have passed pretty far away. But this is the natural, this is Trojan satellites. They actually diverted a lot of the asteroid because they're very massive guys. So they managed to change their orbit, so they didn't come to the solar system. So-called that flung out to the outer solar system. So they're very good. Actually, we have photographed asteroid hitting Jupiter and Saturn before. You see the impact crater? Real time, we saw them. Okay, you compare this to Earth. If this were to hit Earth, it would be bad news. So the asteroid movie, you know about that. It's only sci-fi, but then, well, Jupiter took care of it. And Saturn, you say, where's the hit? Aha, the rings. The rings, they think are Saturn breaking up incoming asteroids. And they guided by the Shepherd satellites, and now they found beautiful rings. The moon has no rings so far, okay? So we are blessed in the solar system in our particular config. This is a real time. One time we actually predicted a comet, is a Shoemaker comet coming in to hit Jupiter, and Hubble Space Telescope was that in function at the time. And they prepared for this and actually saw this real time hitting and all these blocks, okay? Shoemaker-Levy 9. They predicted its trajectory and they expect it to break up under Jupiter's gravity, and they did. And so it was spectacular. People were screaming in front of the control screen, they, hey, here's one, here's one. So they actually protected us. So the train of all these debris, when they hit Earth, is not that fun, okay? But when it hits Jupiter, it's just nice observation. Okay, so that's the end of what I prepared. This is just a Bible verse. He fashioned and made the earth. He found that he did create it to be empty, but formed it to be inhabited. He said, I want it to be inhabited. So I control everything. And so I create a moon for Earth. So we need to thank God for the moon. So that's all I have now. Questions? If you want to stay, you're not
Thank
in a
you.
hurry to get in there.
Thank you, Dr. Cheung. And I guess, Michael, are you the one who sent me the email?
Yeah, I sent you the email earlier. I thought I wouldn't be able to make it today, but I really wanted to come, and I'm glad I did. So I can tell my friend now, who's an atheist, I think the top two reasons why we need the moon are because of the moon's impact originally in Earth's early history, that deposited more iron in our core, so we have more of a magnetic field. That's one of the major reasons. And then the other one is it stabilizes our axial tilt for the seasons. And there were some other reasons, but I don't remember what they are right now.
There's a lot of reasons, but thank you so much.
Yeah, thank you.
They are all documented in Hugh's book. So if you want more detail, go to Improbable Planet. I have given Improbable Planet to many of the young adults in our church, and also to a lot of non-believers. One time, you have to watch for it around Christmas time. Sometimes Christian books have them on sale. That time I bought up a whole bunch. It's $1 each. It was like so incredibly cheap. I bought out a whole box, and I think I'm almost exhausted my supply. But even if you buy it, new, it's not that expensive.
I'll definitely get the book and read it when I have time, and maybe give it to my friend too. Thank you.
So Dr. Cheung, we have a question here on the chat. How do we know what proto Earth was like? Where did the planet that collide with it come from? Shouldn't the present Earth have a radically different composition at the point of impact? Well, it's kind of a lot of complicated questions.
We don't, the composition of the impact was really a conjecture from the data, okay? It has to have all that for it to write. We know the end result. That's what we have. We know Earth composition was not like what we have now. Because, we know from asteroid data and the sampling from meteorites, because the meteorites and asteroid, by the way, are what we call the prototesimals, the original protoplanetary nebula composition. That's why we're studying asteroids and all that. They say we think they're pristine, okay? So from those compositions, we say Earth is different than that. Also from isotopic composition. So how come Earth is different than all these other things? We condense from this cloud. Earth is different. So something happened in between. So we know the end result. We know what Earth is like now. So something happened in between, and we know the moon form, and we know the moon's composition now, at least that from the rocks. So the combining of two, so there are multiple parameters fit that. And so they call this impact a Theia, again, after Greek goddess, about the size of Mars. They say the mass from the simulation has to be about the size of Mars. How it hits, some people say it's the racket, something glancing blow, whatever it is, okay? That's how we found out. So we don't know for sure, but we say it's highly probable those what happened. We know Earth was different way that Earth keep changing now, even now, because of all the things that have happened throughout history. Our species has changed, climate has changed. In Hugh's book, it talked about why human being came so late in Earth history, partly because Earth was not ready. Earth's gone through a lot in its, in early life. First, we got the very simple life, but they did something to change Earth's atmosphere. This is the greatest environmental change. Earth's original atmosphere was not oxygen, was nitrogen and reducing atmosphere. That's why they have the blue-green algae. They change Earth's atmosphere. They become the first photosynthetic algae. Some of them still living in Australia Bay, in one of the bay, Shark Bay. And they actually suck in their anaerobic photosynthesis. They don't need oxygen, but they photosynthesize and they breathe out oxygen. And so gradually change what they call the oxidation event, change the Earth's atmosphere to the current composition. So we can have lung breathing kind of animals, including human beings. So Earth's history, especially the atmosphere, changed a lot. And I can't speak because I'm not a geologist, how much the crust itself changed, not the entire composition. When you talk about Earth composition, not just the crust, the interior keep changing. Something that brought up from the crust. And so sometimes when you talk about Earth's composition, sometimes it's an average over the crust and the core and all that. Of course, we know very little about the core of the Earth except from seismic sounding. So a lot of things are still ongoing. Earth's environment has been changing, as we all well know, is warming because of partly because sun's brightness is changing too. So we're not, quote, stable, but we are in the most stable period of Earth history. And Hugh Ross claimed this is God's plan to save mankind, so that salvation can be preached throughout the world before everything is destroyed, because before this physical universe has to pass away, because this is not it. Earth and the heavens will pass away, as Jesus said. One day, everything will be gone. We don't know how it will be gone, but current situation is not very nice with the global warming, all the climate change, all that. But it has been the most stable the last 10,000 years or so. In the church, in the Earth's history, a lot has changed. But I forgot what the question is, but actually things have been changing, and we do a lot of conjecture in that area. But that's as good as we know now. We have more answer than we had like 30 years ago about the atmosphere, about the composition and all that.
Thank you. Now we open up to open question. You
This is
can
a little bit off topic. It's not off topic. There's a website. There's an astrophysicist, Sarah Sylviander, and she was working with someone else like Gerald Schroeder. I forget his name. I read this a couple of years ago, but the 6 days of creation, they map it to how the space-time expanded through as the universe expands. So the first day maps to a 24-hour period in how it was back then, the first 6 day, and then the next 24-hour period was in relation to how, it's hard for me to explain it right now, but it's kind of like, it has to do with this space-time expansion of the universe. And I was wondering if I could email you, Dr. Cheung, about this and ask about this if you have some time later. I know you must be busy, and so am I, but it'd be interesting to talk about if you had the time.
From what it sounds, okay, from the little you have said so far, I think their website is likely a young Earth website because they believe in.
No, it's not young
24
Earth. It's old Earth. It's old Earth, but it's like it maps the first 24 hours to the mechanism for how the 24 hours happens is from the
Oh.
perspective of God at the beginning. So as the universe unfolds, because 24 hours back then, as the time expands, is more time later on, if that makes sense. It has to do with like space-time expansion.
Website subscribe to the theory that a day is 1,000 years and 1,000 years one day. That's just
Not like that. It's actually very scientific. It has to do with how when your space-time expands, your time is slowed down. Kind of.
No, I don't think that will be a valid explanation.
It's I'm not explaining it right now, but it did make
I
sense
know.
scientifically when they said it.
Hey,
It doesn't
Michael.
have to do with it doesn't have to do with young Earth. It doesn't have to do with a day is 1,000 years and 1,000 years is a day. It has to do with the Big Bang theory and the expansion of the universe, general relativity, things like that.
Michael, why don't you send the, oh, I got your email from a chat.
All
And
right,
I can
I'll email you, David.
Yeah, you email me. I don't know why they have to coin the 24-hour, because back then, the 24-hour is a present day Earth's rotation concept.
Right, right.
So back then, it might not be 24-hour, it might be 1 hour, might be 20 hours.
Right. It doesn't matter, but
It
this
doesn't matter, but anyway.
this site's really scientific, and I just wanted Dr. Cheung's opinion on it because she was saying, "Let there be light." That has to do with how the Earth lost its thick atmosphere, became a thin atmosphere, and then allowed for photosynthesis. So that's I suppose her interpretation of Genesis account of creation, or part of it anyway.
Well, that's Hugh Ross' explanation and a lot of reasons to believe people subscribe to it.
Okay.
I wouldn't say it's 24, it's undetermined length of time, a very long length of time. We cannot put a human time on it, but to use time dilation to explain it, I don't think it's very good. Because time dilation has to do with a relative, whether from your time frame versus somebody else's time frame. So, I mean, I don't know how valid that is really. I'm not sure. Okay. I've never heard of explanation.
I do have the link. I do have the link.
Old Earth explanation, but that one is the first time I heard about this. Actually, Hugh's book, Navigating a Genesis, he explained a number of different theologians' point of view about how to explain Genesis 1 with different kind of, some people think the days overlap, some people think that they're not consecutive, and something that they say this has nothing to do with real physical time anyway. There are different ways of looking at it. But myself as an astronomer, I think, just the relativity part, I think is perfectly fine for me to accept the currently scientifically determined time that the universe as we know it is 13.7 billion years old and the Earth is about 4.5 billion years old, because that's from the radioactive data.
I included a link if you want to check it out. It's a quick read. It's a very quick read. It's 141 sentences about, roughly.
Okay.
So
but I have not seen that.
just have a comment here, and I appreciate your explanations that the initial rotations of Earth, it's got to be very fast. It's less than 6 hours. It probably take quite a while in eons to get to a 24-hour rotation rate as in today. So if you look at Genesis 1, the sun, Earth, the solar systems and the moon didn't establish until day 4. So anything before day 4, day 1 to day 3, is really ridiculous to talk about a 24-hour time frame, because there's just no way that God's going to confuse me by telling me a 24-hour rotation rate where the sun, moon, and Earth's not even, it doesn't even exist as if it was today. So, you know, it's kind of a moot point. So I'm going to stop there. But I do have questions about, if you look at other planets, there are a lot of moons. A lot of them have quite a number of moons, and we only have one. So is having more moons will give us more stability, or having more moon it will be detrimental to the Earth? How should we think about it?
It has to do with the mass of the moon. Like Saturn and Jupiter have so many moons. To them, it's just a little rock orbiting them because the relative mass is so different. So just adding, like if you're carrying a bag, you add a P to your bag, it doesn't matter. It's the relative gravity because the moon is so large compared to the Earth, compared to the other satellite. That's why it matters so much. If you add another moon, the whole system will be changed, the same size. It's how large that additional moon will be that matters. Somebody could do the simulation.
More moons will further slow down the rotation rate.
Yeah, we'll further slow it down, but what's the point? Is the thing,
That's
you know.
Right. That's right.
Why do you want it to slow down further?
The relative size is so big of a difference. It's almost like our Earth, the size of our Earth. If we have a big satellite, you'll be considered as a moon. If you put the Earth the size of Jupiter, and its moon goes around it. So it's a relative of the moon, the size of a moon versus the planet itself that matters.
Yeah.
As a biologist, I think, you know, I can appreciate it. We do need a good 6 to 8 hours of sunlight for plants to make carbohydrates from the sunlight, as well as for ourselves to make enough vitamin D so that our bone gets strong enough. And I can imagine that if we have shorter sunlight, and a lot of things will get messed up. So we're just at the Goldilocks time where the rotation of 24 hours is just right for us. So we have enough sun so that we can keep everything balanced. It will drive me crazy if, you know, if every hour someone turn the light on and off. It would drive me crazy.
This is for life as I mentioned many times. We are just actually using from what we know. We don't, there are people who say went as far as to say, well, some life might not mind every 4 hours, but we don't know such life. That's all I can say. But for the life as we know it, for the plants, for the animals, we know it, they want this 24 hours. That's what we are getting used to. So I cannot say, you know, medically and also physically, and for a lot of people, we are so used to what we know on Earth. We have, again, an example of one, and that's why we are so unique. We are trying to find a twin so far from the other places, but so far we have not been successful. We're just trying to find it.
Yeah, it's interesting. Dr. Chow, he is a PhD in immunology, so he is expert in a very, very small stuff. and so thankful. Hey, Dr. Cheung, I have a question. So I heard NASA has another mission coming up pretty soon to actually send human to the moon. Are we done with the moon as far as exploring the rock, or are we going to do more? What are we going there for? Trying to set up a colony, see if there's a feasible place that we can land our feet on there? Well, do you know anything about what NASA is trying to do?
Yes, I do. Because before I retired, they're already talking about it, because NASA has a very long planning horizon. By the way, all the mission we got nice planetary data on were planned 50 years ago. So, well, as an example of excellent project management, we are planning things for the next generation to carry out. All the pretty Voyager images were planned way back in the 60s. And now it's just returning data. yes, we do plan to go back to the moon. There has been talk long time ago, if not for the budget that Congress, the minuscule budget that Congress gave to NASA, because we're no longer in the moon, in the moon race. Compared to the Apollo time, NASA's budget has been cut drastically, but doing a whole lot more. The reason we want to go back to the moon, besides that we don't know the moon that well yet. We have been only to a couple of places. Like you say, do you know United States? You have only been to places. You have been to New York, you have been to San Francisco, and say, you know, it's the United States icon. No, you don't know United States. You have not been to a lot of places. We have not been to the backside of the moon, by the way. We have not. No human geologists have to be the backside. We don't have samples from the highlands. We only get this, that's why the dispute around this impact theory, say you only got rock samples from the Maria, which is the flatland, what they call the ocean, okay? So it's a small sample. They say you only concentrate on a few places, only 3 missions that brought back some rocks. And you only sample in a few places on the plane and say that's not sufficient. What if the highlands are completely different? We don't know. We don't have any. The other reason for going back to the moon, because one time we have this push, not from NASA, but from high up in the administration, say, we want to go to Mars. Okay, before they understand all the radiation hazard, we want to go to Mars. So how are we going to Mars? Mars has a long delay in communication. It's a lot more hazard. You need to have a training ground. The moon, we know quite well. And also we know how to rescue people from the moon if necessary, because it's close enough distance. Even if something happened, you want to mount a rescue mission, we have sufficient time to go there and back. Whereas in Mars, the transit time is 6 months, my goodness. Whatever happened there, already happened before you can reach them. And even the voice communication, there's a delay. I forgot how long, but it's like more than 30 minutes. So you're pretty much on your own, the astronauts. You have watched the Mars movie, you know what's going on. You're pretty much on your own. So they want to go back to the moon as a training ground to build a lunar base so that you learn how to live in an extraterrestrial place and survive. Can you harvest things from the rocks? Like they say they can harvest water, actually made water, made oxygen out of the rock, because you cannot carry that much rocket fuel. You can go to Mars one way, but how do you come back? You cannot carry the fuel there and back. You don't have such a large gas tank, essentially. So you have to manufacture something in situ. But how do you do that? You have to learn. This is not Earth, okay? You have no electricity. How do you build your solar power plant? How do you dig in an ice cold thing? How do you dig in a permafrost? We don't know. There are a lot of technology that need to be developed if you're going to really go into Mars that far away. So they say, why don't we go to the moon? We know the gravity, know exactly how to jettison from the moon. Eagle has landed, has come back. At least a sufficient number that we are successful. So we might go there and actually use moon as the training ground to do long-term, you want to colonize space, all these streams, okay? You need to learn a lot about medically, what do we do? What if there's a medical emergency, what shall we do? Although they always send a medical doctor as one of the astronauts, but still, you don't have the equipment. So there are a lot of things you need to be prepared. So that's one reason to go back to the moon. But again, the budget is actually the biggest hindrance right now. Why are you going when there's so many other, that's before the pandemic, you have so many national emergency. There's so many, pending items here on Earth. So of course, it's still ongoing. There's still technology being done in preparation for that. The lunar reconnaissance orbit is one thing to map the moon down to a 5-meter scale, because before the map is very crude. Actually, Armstrong landed the Eagle. He's very good pilot. It was not what he expected. He actually manually landed the Eagle down on the area. It's very scary business. He's not sure he can land it because it doesn't look like what he thought it was. So the map was very good. So it's just like GPS put you into the street and you don't know which house it is. So what if you land a robot in there, there's a hole there, you don't even know there's holes, so they have the map down to 5 meters. So lunar reconnaissance is essentially go to a very detailed map so you know where you're supposed to be. You don't want to drop into the hole if you drop something in there. There are a lot of other things, technology, the operational procedure is extremely important. How do you communicate? If you're in the backside of the moon, you need a satellite. The Chinese actually has a relay satellite. The sound wave does not bounce back. So you need to have either you build antennas, relay towers on the moon, or you have a satellite up there in orbit relaying your message. And in Mars is even more difficult. You're not in the line of sight. That's why they always land on the front side of the moon where you have direct contact with Earth, your line of sight. So there are a lot of issues when you deal with operations. One reason I think a Chinese mission, the first one, the bunny never moved because I think operationally they failed. They have not really exercised the sequence very well. It's very difficult in operation. I know because I was in operation before. Yeah, people double check, triple check everything. Do all sorts of what if scenario before you just send a regular command to an unmanned spacecraft to make sure it goes right. Because operationally, there are a lot of things to learn, and that was developed by NASA in terms of executing a mission so that it's not without risk, but it's a calculated risk, minimize the risk of people, life, and resources. So that's the reason we still want to go back, because it's closest training ground. It's far enough away. It's away from Earth's magnetic field. The one thing I was involved in and find out where the astronaut can have magnetic shield when a solar flare hits on the moon, okay? So they did a survey to find out where the natural shields are. One way is to go underground, find the tunnels in the moon. At one time before it cooled down has a bit of volcanic activity, so there are lava tunnels. The astronaut, the best bet is to have mass between you and high energy radiations. The best way is to go underground to a cave. So where are the caves? So you have to look for that. But unfortunately, one of our simulations is the solar flare hits the high energy particles. The highest energy particles will find themselves through the cave. They will go through there first. It's just the way the energetics work. It's just very unfortunate. You cannot cover yourself up with the rover because rover just thin piece of metal is as good as nothing. So just like in a car collision, they say, well, how good is your metal in protecting you? Essentially, it's nothing. If it's crash, it crash. Or if the impact is strong enough. And that's what happened. They say even to the moon, a long-term lunar basis is kind of risky because of the radiation. You have no atmosphere to shield you. There's no magnetic field. How can you generate your own magnetic field? Perhaps, but there's energy to generate the magnetic field. Where do you find the energy? So there are a lot of, what if, how. So they are still working through it in a simulation, in kind of a thought experiment nowadays. A lot of scientists are involved in that. See if we can get outside the Earth's atmosphere. The space station is kind of good because space station is not completely outside Earth's atmosphere. They still have some shield. That's why space station people, the astronaut can use laptops because they are sufficiently shielded. The space computer is very backwards. They're just beginning to use the Apple chip, I think, a few years ago because they are not space hardened, radiation hardened. They cannot use the state-of-the-art Pentium because one sap, you're fried. Okay, you don't have a computer, and computer controls everything. So a lot of difficulty with instrumentation, with building things. A different kind of engineering goes into that, and radiation shielding is extremely important. But the more shield you add in, the heavier the spacecraft get, the more expensive it is to push it off Earth, and you may never get to launch. So it's a lot of trade-off they have to look at. And maybe this is just, they say going to moon may be good enough. You might even have talked about another dream mission about capturing an asteroid as a training ground. An asteroid asteroid is smaller than the moon. So it might be easier to do some things, but then you have no gravity for the astronaut to stand on. You might fly off the asteroid without intention. You might flow away into space. So there are a lot of interesting thoughts. There are people who suggest those things. But the moon, returning to the moon definitely is in the vision itself. You want to go back just to understand more about the solar system, about what we could do if you want to become a really spacefaring nation. But whether we really want to do that is whether we have the willpower. It's unlike in the Cold War, in the space race. In fact, they dump so much resources, it's unimaginable. Nowadays, you trade off a lot of things. You need to spend on social program, you need to spend on so many other things. So that's my answer.
Thank you, Dr. Cheung. I'm surprised that of the $5 trillion that Congress is going to pass, they didn't spend much on the NASA.
It is, I think it's 1%, less than 1% now.
Yeah.
So we had a cheat sheet for us to answer questions from the public. Say, how much are you spending in space missions? I say, well, are you willing to spare that 1%? You're willing, then it's more to do with having a long-term vision about lifting your head above the Earth's problems and actually looking farther and further away. And that actually help. Actually, by the way, space, the entire space effort has contributed more to the Earth technology than you can ever thought of. You won't have today's PC if not for the NASA space race.
Yes.
In fact, a lot of people didn't understand why we won the space race because of computer technology. Russia didn't know how to do the simulation, don't know how to do the orbital correction. Nothing is exact when you launch a spacecraft. You have to continually do corrections and the approximation continually doing it. And that process is kind of very specialized. The guys who do what I call the real rocket scientists, I always tell people I'm not a rocket scientist. The rocket scientists are the one, they all have PhDs, the engineering, aerospace engineers with PhDs. They know general theory of relativity. They know all that. Do the constant correction of the spacecraft to guide it towards the place you want it to. They always do what they call orbit keeping. The housekeeping, what they call the normal housekeeping. You turn your head, sometimes you lose a spacecraft. You don't do it correctly. They have anticipated a lot of things. That's why talking about all this artificial intelligence, we always laugh at it. What artificial intelligence? It's all remote control. Or the brains are down on the ground. That's why they dare not go to Mars, because you lost the brains on the ground. You're on your own. Whatever AI robotics you can bring with the astronauts, I'm sorry. So far, all the NASA robots are remote controlled. You're joysticking them on the ground. There's a team of people, sometimes 1,000, hundreds, working the things daily. Even in the Mars rover nowadays, there are people doing simulation, real-time duplicating how far the Mars rover are moving, which wheel they should turn, and how they put down the thing to dig. So it's not that easy. So
it's a one-way ticket to go to Mars.
Yes, right now it's one-way ticket because of the radiation.
Yeah.
I don't know how, medically, it's really terrible. You read the data, how many rats a person can sustain. Even if you don't die immediately, well, you won't live very long. Madame Curie, she died because she do all this experiment on the radioactive elements. But you're facing that daily and also uncontrolled because you don't know what will come over you in this place without atmosphere. Atmosphere also help to dissipate some of the radiation because you have less mass, atmosphere's mass, and you have the magnetic field. But on the moon, there's no real atmosphere. On Mars, there's no very thin atmosphere. There's no magnetic field on Mars either. So I don't know. How do you shield off something like that? the question is very difficult to answer, and that's why we dare not go back.
Yeah.
A lot of people say, why bother with manned mission? It's just very romantic. They say, well, man can make a lot of decisions, but that is at a very high price. You don't want to lose a human life. You can afford to even crash $1 billion spacecraft. It's a lot of effort going down the tubes, but still no human life is involved. That's why a lot of people say, why bother with a manned mission? Why don't you just go and man? You can do a lot with a man. The human intelligence is very important. Human can make a lot of decisions. The astronaut arrive in the moon. The moment they arrive, they know this is all impact craters. Because I know the geologists who actually train astronauts before they went to the moon. They were not geologists by training, but they have to train them. They don't know when they first step on that way, they will sink down onto deep quicksand or what. They have no idea what the moon was composed of. They did sink a little bit, but not very much. And the moment they saw the rocks, they know it's impact rocks. They say no question about that, because they train them how to recognize the important features. But there are a lot of unknowns still. That's why I say we still need to explore whether we have the will to spend the resources to continue to explore. Besides, computers, there are a lot of other technology, even for medical, the image enhancement technology. I heard space telescope. This is a real case with the breast cancer imaging, the image restoration, because Hubble was launched with a fault mirror. So they restore the image. It was a fuzzy image. And that technology, the restoration technique, was used in breast cancer imaging. And it helped to actually detect better detection of that breast cancer. So there are a lot of spin-off in the space technology, although it was not intended to be used that way. The remote control, the communication. Again, the communication, if not for NASA, you won't have today's, of the GPS was not NASA, GPS was military. But a lot of navigation system, if not for NASA, you won't have that. There are a lot of impact, the radio waves, the radio communication. Your cell phone nowadays own a lot to NASA technology. Because they need to be able to pinpoint you. You're sitting next to a friend, you have two different numbers, but his phone would never ring because it's your number. How do they distinguish between that? The communication technology comes into play there. So there are a lot of things that develop that advance our technology because of the space program, or they are spin-off. They're not targeted from that, but that's the way with science. You do not know what the benefits are until you really, go for something. That's why they say curiosity-driven research has a lot of benefit. And some people are saying, well, what's the application? Congress asked, what's the application? I cannot answer you now until let me answer this very interesting question. Application may come in very unexpected ways. You say it's useless. I don't know whether useful or not. But you don't let me go forward towards this thing that's begging, to be explored. I don't know what the results will be.
All right, thank you so much, Dr. Chen, for presenting to us the moon, and we thank you so much. And that was wonderful to give us a marvelous lectures and discovery about the moon. And so just a little advertisement. So next month we'll have Dr. Gonzalez. He also worked at NASA before, and he's going to talk to us about fine-tune. And then in November, we'll have our own Ray Usar could talk about C.S. Lewis and his views on his views about atheism. Very interesting talk. And then we take a break in December. In January, we'll have well, I've forgotten the name of this expert to talk about a climate change issue, an expert in climatology. So we'll have an excellent lineup here. Thank you so much. And hey, Paul, can you pray for us to close ourselves in prayer?
Yeah, I can do that.
Thank you.
Sure. Heavenly Father, thank you, Lord, for for this evening, for this time to get together to discuss and learn more about your creation. It's the more you learn, the more fantastic and amazing it becomes, and the bigger and bigger you get because you're the one that built it. So thank you, Father, for this time. Thank you for all the folks who showed up. Thank you, Dr. Cheung, for presenting it. It was all very informative and brilliant. And so we're just so grateful that we get an opportunity to look at in detail what you've done. And it's so absolutely amazing. So thank you, Father. Thank you for this time. And we just want to remember Jesus, of course, who makes all this possible. So in his name, amen.
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 Thank you, everyone.
Thank you, Dr.
And-
Cheung.
Thank you.
And
It's
see you
interesting.
next time.
Bye. Thank you.
Bye.
Bye-bye.
Bye.
Thank you for your presentation. It was very interesting.
Yeah, my pleasure.
Thank you, Dr. Cheung.